Hello everyone, I'm going to show you how to solve the truss problem in the Ansys 19.2. So this is the given problem. It is a 4-bar truss. Here we have 4 elements. This is first element, second element, third element and fourth element. And it is having 4 nodes. So we'll consider this as first node, this one as second node, third node and fourth node. This first node is fixed in all degrees of freedom, and also this fourth node is also fixed in all degrees of freedom. The second node, it is fixed in y direction, but it can move in x direction. On the second node, a load is applied of 2000 Newton, and on the third node, a load is applied of 2500 Newton in negative y direction. The load is acting in downward direction. So for this problem, he has told to find out the stress in each element, reaction forces, and the displacement of the nodes. Young's modulus is 210 gigapascal, and the area of all the elements. Here the area of all the elements is 0.1 meter square. So to solve this problem, to find out the stress in each element and reaction forces and nodal displacement, so I'll open the software, click on mechanical APDL 19.2, go for preferences, select structural, click on OK. Next go for preprocessor, element type, add, click on add. Here select link 3D finite strain 180, click on OK, close this. After that go for material properties, material models, select structural. In that you select linear, elastic, isotropic. So enter the Young's modulus value, it is 210 gigapascal, 210 10 raised to 9, and Poisson's ratio, if it is not given, you have to take it as 0.3. Click on OK, close this. After that go for sections, go for link, add. Here you give the section link with ID number 1, click on OK, and here you have to enter the area value of each element. So here the area of all the 4 elements is 0.1 meter square. So I'll enter the value 0.1. Next go for modeling. We need to create the nodes and we need to create the element between the nodes. For that go for modeling, create nodes in active coordinate system. The position of the node 1 will take it as 0 in x direction and 0 in y direction. So here you enter 0 in x and 0 in y, click on apply. The coordinate of second node is in x direction it is 4 and in y direction it is 0. So here I'll enter 4 and in y direction it is 0, click on apply. The coordinates of third node is in x direction it is 4 and in y direction it is 3. Apply. And the coordinates of fourth node is in x direction it is 0 and in y direction it is 3 meters. 0 and 3, click on OK. If there is a fifth node, under that condition you have to click on apply. Since here we have only 4 nodes, I am clicking on OK. Here you can see the 4 nodes. Next, the element has to be created between these all 4 nodes. For that go for elements, auto numbered through nodes. Select first and second node, click on apply. Select second and third node, click on apply. Third and fourth node, apply. Third and first node, click on OK. Now next is we have to apply the boundary conditions. For that, go for loads, define loads, apply structural displacement on nodes. Since first node and second node are fixed in both the direction, that is in X and Y direction, so I will be selecting first node and fourth node, click on OK. So fix that it in X and Y direction. So I'll select UX and UI and I'll click on OK. So this first and fourth node are fixed in X and Y direction. Now the second node, it can move in X direction, but it is fixed in Y direction. It cannot move in Y direction. Again, I will go for on nodes, select this second node, click on OK. And here I will select only UI. Next, you go for force movement on nodes, select second node, click on OK. And here the load acting on the second node is 2000 Newton, which is in positive X direction. Direction here I will select as Fx, and here I will enter the value as 2000. Again, you select on nodes, select this third node, click on OK. Here it is acting in negative Y direction, and the value is 2500. So here I will enter the value minus 2500. The reason is it is acting in negative Y direction. Click on OK. Next, go for solution, solve current load step, click on OK. Solution is done. After that, go for general post processor, go for element table, define table, add, and here you select by sequence number and ls comma 1. So this will give you the stress in each element. Close this, go for plot results, counter plot, line element results, click on OK. So here you will be getting the stress in each element. So next, if you want to see the displacement of the nodes, for that go for list results, nodal solution, degrees of freedom solution, displacement vector sum. So here you can see the displacement of each and every node in X and Y direction. Since this first node and fourth node are fixed in both X and Y direction, so their displacement is 0 in X direction as well as 0 in Y direction. So this will give you the displacement of each and every node. Now, to know the reaction forces, you have to go for reaction solution, select all items and click on OK. So it is going to give the reaction forces acting on each and every node. Thank you.